Hello everyone. So today we will be discussing about the questions which are of logarithmic inequality. So without wasting any time, let's start. The first question that arises is log of x log to the base x 4x plus 5 upon 6 minus 5x less than minus 1. Now in this case we are having a variable base. Whenever we are having a variable base, sorry, we will take the two possible values as the base is either greater than 1 or the base value lies between 1 and 0, right? uh, I'm assuming that you are having a prerequisite knowledge of the logarithmic inequalities and logarithmic functions, right? And only then you can continue watching the video, or if you just want to enjoy the show, you're most welcome, right? So whenever the base is variable, then there are two possibilities. The one possibility is that the base is greater than 1, and the other possibility is that the base is in between 0 and 1. So when the base is greater than 1, in that case, we are having x belonging to 1 to infinity. And when the base is in between 0 and 1, in that case, we are having the values of x belonging to 0, comma 1 with both open intervals, right? Now we need to solve the inequality for both the cases. We need to solve the inequality for this case as well as need to solve the inequality for this case. And after solving the inequality, we will proceed with our answer. So let's start. So taking the case 1, taking the case 1 when x is greater than 1 or x belongs to all the values from 1 to infinity, right? So our inequality is log 4x plus 5 upon 6 minus 5x to the base x less than minus 1. Now notice that x is greater than 1, the base is greater than 1. So whenever the base is greater than 1, so for shifting the base to the another side of the inequality, we do not need to change the sign of inequality. So it becomes 4x plus 5 upon 6 minus 5x less than minus x to the power minus 1, right? We can solve it further as it could be solved as 4x plus 5 upon 6 minus 5x less than 1 upon x, right? Both the side are having the variable part, so we're not going to multiply but shift the any one of its side to another side, right? So what you can do is 4x plus 5 upon 6 minus 5x minus 1 upon x less than 0. We will then take the LCM. So after taking the LCM, I can say x into 6 minus 5x into 4x plus 5 into x minus 6 minus of 5x. It's less than 0. On solving it, I will get 4x square plus 5x minus of 6 plus 5x upon x into 6 minus 5x less than 0. Now we can write it as further 4x square plus 10x minus 6 upon x into 6 minus 5x less than 0. Now in the numerator we are having a quadratic equation that could be factorized into the factors as it is 4 into 6 24. So 12 plus 12 minus 2 is 12 and 12 into 2 is 24 and 12 minus 2 is 10. So I can write it as 4x square sorry 4x square plus 12x minus 2x minus 6 less than 0 divided by x into 6 minus 5x less than 0. It could be further written as on factorizing 4x 4x plus 3 or taking 4x as the common part taking 4x common, x plus 3 minus 2 x plus 3 whole divided by x into 6 minus 5x less than 0. So after factorization, what we are left with is 4x minus 2 into x plus 3 divided by x into 6 minus 5x less than 0. Now the inequality is solved, but we have to solve the inequality by giving the intervals. But now the first step to consider here is that here is 6 minus 5x. So as the negative sign is with the variable part, so to alter that, as I want to put the negative sign with the constant part, what I can do is I can multiply both the sides of inequality with the negative sign. So what I'm doing is I'm multiplying both the sides of inequality with negative sign. So it will become 4x minus 2 x plus 3 x into 5x minus 6 greater than 0. Why greater than 0? Because we have multiplied it with the negative sign, and as we have multiplied it with the negative sign, the sign of inequality reverses. Okay? Taken? So this happens. It could be further solved as 2x minus 1 into x plus 3 divided by x into x minus 6 by 5 greater than 0. Now, this is the inequality. We can solve it by plotting the critical points. So, the critical points are 0, 1 by 2, 6 by 5, and minus 3, right? Plus, minus, plus, minus, plus. As there is no extra power, no even or odd power over these expressions, so I can just alternately write plus minus plus minus plus minus, right? And now as the inequality suggests that we have to take the greater, so we will take the values which are having the positive, which gives the whole expression positive part. So what will be the answer? This 6 by 5 to infinity, 0 to 1 by 2, and minus infinity to minus 3, right? So the x belongs to minus infinity to minus 3 union 0 to 1 by 2 union 6 by 5 to infinity. This will be our answer, right? But this is not the actual answer, because we have to take the intersection, take the intersection of this with the condition that we have assumed for the base, which we have assumed for the condition that we have assumed for the base, right? We have to take the intersection with that. So for taking the intersection, what I can do is I can simply plot the point. I can simply plot the point 1 here. The point 1 will be somewhere here, and it says 1 to infinity as the point, the base inequality, the condition for x in the base. So 1 to infinity. So the common part that comes here is this part. Hence, we can say intersection, on intersection with x greater than 1, our answer for case 1. Answer for case 1 will be 6 by 5 to infinity, right? Now we need to take the case 2. For taking case 2, I can simply take I can simply say that the value of x is less than 1 and greater than 0. If the value of x is greater than 0 and less than 1, in that case, again we will solve the inequality. So the inequality is minus 5x less than 1. Now, important part here is that as the base is less than 1 and greater than 0, hence when we will shift the base from one side to the other side of inequality, the sign of inequality will change or will reverse. So what I can say is 4x plus 5 will 6 minus 5x. Now it will be greater than x to the power minus 1, or I can say 4x plus 5 upon 6 minus 5x will be greater than 1 upon x. Now we will solve the similar way that we have did in the earlier case. So I can solve it for 4x plus 5 minus 1 upon x on 6 minus 5x greater than 0, and it will become again the same case 4x square plus 10x minus 6 upon x into 6 minus 5x greater than 0. We can further solve it 2x minus 1 into x plus 3 upon x into 6 minus 5x greater than 0. Further, we can solve the inequality as x minus 1 by 2 x plus 3 upon x into x minus 6 by 5 less than 0. Now there is a change that I have made again in this case because again in this case 6 minus 5x is there. Now I have to reverse, or I want to reverse the sign of constant and the variable so that I can solve the inequality. So for that I have multiplied both the sides with the negative sign, and hence after multiplying this by the negative sign both the sides of inequality, it will result in the change in the sign of inequality. So the critical points here will be 0, 6 by 5, 1 by 2, 1 by 2, 6 by 5, and minus 3. Now again plus, minus, plus, minus, plus. Here we will consider the minus part because not the minus part. I will only consider the part which is showing us, which will give us the value less than 0. So what all are the values? 0, minus 3 to 0, and 1 by 2 to 1 by 2 to 6 by 5. So our answer here for the interval will be x belonging to minus 3 to 0 union 1 by 2 to 6 by 5. Now, is the final answer for the case 2? The answer is obviously no, because we have to also take the condition of the base that we have taken initially, which is which is x belonging to 0 to 1. So if x is belonging to 0 to 1, that means 1 will be somewhere here, and x belonging to 0 to 1. That means the common part that is coming is 1 by 2 to 1. So on intersection, on intersection with x belonging to 0 to 1, we get we get the value we get the value or the interval for case 2, for case 2 where x is less than 1, greater than 0, as x belonging to 1 by 2 to 1, right? So this is how we can take this is how we can calculate the answer for case number 2. Now case number 2 or case number 1, both the cases are needed. Both the cases are needed because we are not knowing that what is the value of x. So I can say we will be taking both the cases, and for when there is or in between the cases, or when we can say we have to take the both cases, then we will take the union. So the answer for case 1 was the answer for case 1 was 6 to 5 6 by 5 to infinity, and the answer for case 2 is 1 by 2 to 1. So our answer will be answer for both cases will be 1 by 2 to 1 union 6 by 5 to infinity. 1 by 2 to 1, 6 by 5 to infinity. But again, is it not the final answer? Because the domain part is still left with us. So to calculate the domain, we must say 4x plus 5 upon 6 minus 5x is 6 minus 5x is greater than 0, as the domain value must always be greater than 0. So again, changing the sign of the denominators, I can write it as 4x plus 5 upon 5x minus 6, 5x minus 6 less than 0, or I can write it in the form x plus 5 by 4 upon x minus 6 by 5 less than 0. We will draw the points for this. So for drawing the points, minus 5 by 4, and it is 6 by 5 plus minus and plus. We have to consider the cases where x is less than 0, right? Why less than 0? It was initially greater than 0, but we have altered the sign of 5x minus of sub 6 minus 5x, so that the 5x, the variable part, comes with the positive sign for solving the inequality, and hence on multiplying both the sides of inequality with negative sign reverses the sign of inequality. So this is what we have got, and we have to take the case from minus 5 by 4 to 6 by 5. Now at last we are having the values of which are in the domain. We are having the values which we have calculated for the cases. We will be taking the final intersection of these all values to calculate our answer. So we will number line, draw one final number line, and we can write minus 5 by 4, then 1 by 2, then 1, 6 by 5, right? So the domain ranges from minus 5 by 4 to 6 by 5, and our the answer for both cases ranges from 1 by 2 to 1 and 6 by 5 to infinity. It is obvious that the only common part is this. So the answer for our inequality, the final answer, the final answer for above inequality, above inequality will be x belonging to 1 by 2 to 1. This will be our final answer. The question was quite lengthy, but it was fun to solve this question, right? You must also agree to it. If you agree to it, give a thumbs up. Okay. So now the next question, question number 2, log x to x plus 4 x square minus 8 is greater than log x plus 4 x square minus 2x minus 8, right? Now in this case, uh, we again have to do the same thing. There is variable base. As the base is variable, so we need to calculate the two cases. when x plus 4 is greater than 1 and when x plus 4 value is less than 1 but greater than 0. So when x plus 4 is greater than 1, that means the value of x is greater than minus 3. So let's solve the case number 1. Case number 1, when x plus 4 or the base value is greater than 1. As the base value is greater than 1, so we can solve it very easily as x square minus 8 greater than log of x plus 4 into x square minus 2x minus 8. Now, as base is greater than 1, so we can cancel the log easily without changing the sign of inequality. Because the base is greater than 1, so it will not affect the sign of inequality. And hence, what we were left with, and hence what we are left with x square minus 8 greater than x square minus 2x minus 8. X square minus 8 is getting cancelled by x square minus 8 and we are left with 0 greater than minus 2x or x is greater than 0 or x is greater than 0. The the condition for the base suggests that x must be greater than minus 3 and by taking that condition we have solved the inequality, and after solving the inequality we have got that x must be greater than 0. So the only intersection will be x greater than 0. Even if you can't understand it, you can draw this with the help of number line as minus 3 and 0. So the condition for the base was minus 3 to infinity, minus 3 to infinity, and the condition for the case that we have solved after solve the inequality was 0 to infinity, right? So in both the case the common part is 0 to infinity. Hence the answer the answer for case 1 the answer for case 1 will be x belonging to 0 to infinity. Now we can solve for case number 2. For case 2, we know that x plus 4 is less than 1 but greater than 0. Or we can say that x is greater than minus 4 but less than minus 3. X is greater than minus 4 but less than minus 3, right? And for this particular case, we need to solve the inequality once again. So I can say log x plus 4 x square minus 8 greater than log x plus 4 x square minus 2x minus 8. Now we can cancel the log part here also. But because the base is between 0 and 1, in that condition I can say that the sign of inequality will reverse. So the I can cancel the log, but the sign of inequality will reverse. So x square minus 8 is less than x square minus 2x minus 8, or I can say or I can say that x is less than 0, right? Again, if x is less than 0, but this is not the answer for case 2 because we also have to keep in mind the condition that we have established for the base, okay, and on which basis we have solved the inequality. So plotting the points, we can get 0, minus 3, minus 4, minus 4 to minus 3, and 0 to infinity. So the obviously common part is minus 4 to minus 3. Hence, answer for case 2 answer for case 2 will be minus 4 to minus 3. Answer for case 2 will be minus 4 to minus 3. So as we were not knowing that as we were not knowing the base initially, that what base is, that x plus, oh sorry, the as we were not knowing that the base was uh, greater than 1 or smaller than 1. So we have taken all the condition, and as we have taken all the condition, now we will be adding these conditions. What I mean to say, that there was or in between these conditions, and as there was or in between conditions, we will be taking the union of the union of these conditions. So the first case gives us the value x belonging to 0 to infinity, and second case gives us the value -4 to -3. The values of x belongs to -4 to -3. So I can say that the answer for both cases answer for both cases will be answer for both cases will be -4 to -3 union 0 to infinity. Right? Now, this is the answer that we have calculated, but this is not the final answer, as still the domain part is left with us. So to calculate domain, we need to calculate x square minus 8 greater than 0. Now, where the x square minus 8 came from? As this part, x square minus 8 greater than 0, and x square minus 2x minus 8 greater than 0. Right? We have to calculate the values x square minus 8 greater than 0 and x square minus 2x minus 8 greater than 0. The values which satisfy both these values, these conditions, will be the domain of the whole inequality. So it can be expressed as x minus 2 root 2 into x plus 2 root 2 using a square minus b square greater than 0. So the value of x will be minus infinity to minus 2 root 2 union 2 root 2 to infinity. And for this case, I can say that x square, it can be factorized into x minus 4 into x plus 2, right? Greater than 0. So x belongs to minus infinity to minus 2 union 4 to infinity. Right? Now we will plot these points, and after plotting the points, we will calculate after plotting these points, we will calculate the final domain of our inequality. So I can say that minus 2 root 2, then minus 2, then 2 root 2, and then 4. Now let me first check the value of 2 root 2 is. So we have plotted this minus 2 root 2 minus 2 2 root 2 and 4, right? And now we will be uh, taking the values minus infinity to minus 2 root 2 and 2 root 2 to infinity, and 2 root 2 to infinity, right? Then minus infinity to minus 2, minus infinity to minus 2, and 4 to infinity. So of course the common part is this one. This one is the common part, right? And I can write as the domain of the inequality will be x belonging to minus infinity to minus 2 root 2 union 4 to infinity, right? This will be our this will be the common or the domain of the above inequality. Now, if this is the domain of the above inequality, then we can say that the the intersection of domain with cases will give the final answer, will give the final answer to our inequality, right? So what were the cases answer? Minus 4, minus 3 and 0. So again, we'll draw one more number line. Minus 4, minus 4, minus 3, minus 2 root 2, then 0, 4, right? And now we will plot as the domain suggests that minus infinity to minus 2 root 2 and 4 to infinity, and our case suggests minus 4 to minus 3, minus 4 to minus 3 and 0 to infinity, 0 to infinity. So of course the common part is observed clearly. This is the common part, and if this is the common part, I can say the final answer for above inequality, for above inequality will be, for above inequality will be x belonging to minus 4 to minus 3 union 4 to infinity. This will be our final answer. So yeah, it's me, Prakhar Jain. If you like this video, give a thumbs up.